Good afternoon. How was everybody? You having a great show? Great. So my name is Jeff Price. I'm with a company called 5ME. All right, and so I'm going to talk to you a little bit about one of our products. I'm an executive vice president for 5ME, but I'm also the general manager of the Freedom Smart Manufacturing Platform software. And we're going to talk a little bit today about getting more from your plant floor and a lot about how to get started, with machine monitoring. We're going to talk a little bit about our company to start off with. We're going to talk a little bit about the quest for data and all the disparate data that's out on the shop floor today, and how do you wrangle that, into some discipline. And then we're going to talk about some of the deployment options and a little bit of some of our software as well. So let's start off. Oh, by the way, is that you can see our technology in action, monitoring real machines. You can see us in the MAG booth in the South Hall. You can also come by and see us at the Sagino booth, also in the South Hall. And you can see us monitoring machines in real time in both those places. To start off with is that just a little bit of history, is that 5ME has been around we're just celebrating our 5-year anniversary. However, a lot of the technology has existed in another form in another company called MAG, all right? And MAG was a $1.8 billion industrial automation company, machine tool company, from about 2005 to about 2013, comprised of some really historic brands like Cincinnati Millicron, Giddings & Lewis, Cross-Hewler, Excello, and so on. And so in 2013 is that we spun out with two technologies. One is the manufacturing software platform that I'm going to talk to you about today, and the other one is a cryogenic technology where we're using liquid nitrogen through the spindle instead of traditional coolant. All right, so our roots are really deep into the manufacturing side as well as into automation, and into the manufacturing IT side. We focus on a lot of discrete manufacturing industries, so pretty heavy in construction, aerospace, energy, transportation, ag equipment, and we're starting in the medical devices. So pretty diversified in some of the markets that we play in. Again, a lot of heavy manufacturing, discrete manufacturing. For the Freedom side of the business, which is our manufacturing software platform, is that it consists of our flagship product, which we called Freedom eLog. And basically what our product does is we connect to any asset on the shop floor. So we're asset agnostic, and that we can collect any kind of information from any device. It doesn't matter, if it's a legacy device or a very modern machine tool. What makes us a little bit unique is that because our roots are in manufacturing and machine tools and automation, is that we also bring a lot of consultative approach when we're connecting these machines. So we can talk about operations, we can talk about manufacturing, turn right back around and talk to the IT group. So we're a pretty good bridge when it comes to, operational technology and informational technology. Okay, so let's talk about the quest for data information. Is that I put this up here just to talk a little bit about some of the industry challenges. The point is that margins are tight, right? And so we're trying to squeeze every bit of dollar out of the operation and take it right to the bottom line. I've been in operations for a long time in my career, and I can tell you, is that most of the time is that my manager would always come and ask for 6% productivity improvement year on year. Then ask me for the programs of how am I going to get there, right? So I can give you 6% cost reduction. That's pretty easy on a piece of paper, but then when they start asking you for what are the programs and what you're going to do, then it becomes more difficult. And the challenges are even harder because of what the environment is that probably one of the biggest challenges that we saw as a machine tool provider and as manufacturers ourselves was that we found that just getting qualified operators, is a huge problem, just someone that can actually run the machines. It's a global environment, so in other words, you have competition from all over, so it's a little different than it was, say, even 20 years ago. The lot sizes are smaller, the quality requirements greater. So the point is that it's a razor-thin margin business, and anything you can eke out, as fast as you can is the best way to go. And so a lot of people then went to continuous improvement programs. We were really heavy into lean manufacturing and Six Sigma and other things like that, all right? But all of that requires data, and we usually took a long time to try to get to that data and try to get to the root causes of some of the manufacturing problems that we ran into. So what we can bring is that we can bring solutions to some of those challenges. So one of the problems with getting that technical data was that we all did it on clipboards for a while. So then we decided that maybe we can get it from the machines themselves. Well, that had a wide variety of challenges. Is that I've never been to a factory yet that it was a homogeneous environment. You've got a duplex mill that's 50 years old, and you've got a Mazak machine that you just bought, and you've got all kinds of controllers, all kinds of machines, so it's just not a homogeneous environment. And with all of those machine tool brands and their controllers, is that there's always some sort of custom API what it takes to get the data out of the control. All right, so there's ways to do it. Every one of them is a bit different. So how do you standardize that? You also have to deal with connectivity issues, with network infrastructure and security and communication protocols. So, even though we can connect them now, there's still a jungle to wade through out there. And also is that how can we make this expandable? Is that we start with a small data set. We'd like to actually monitor more and more and more, as time goes on. So how can we grow, at the same time? So a lot of that can be such a challenge that a lot of the customers that we work with is that they have a hard time getting started. So it seems like a daunting challenge. So our whole advice is that, hey, certainly begin with the end in mind, but just let's get started. So, but I think what it really comes down to is that when you embark on a machine monitoring solution, is clearly define your problem. What are the pain points? Is it a capacity issue? Do you feel like you have excessive downtime? You're trying to get a handle on some of the operating environment. So I think financially is try to identify really what it is that you're trying to achieve. Call it use cases. Then decide how you're going to measure success. What will success look like once you get there? What kind of culture is going to be required to maintain it? It works a lot better in a continuous improvement culture where you can involve everyone. Is that this is a lot of automated data collection and actionable information, but it still requires people to make it work. It's automated as it is that the better that the culture accepts it and works with it, the better off and the more successful that a project like this will be. Select a champion. So when you're going to put a monitoring solution, or just like any other continuous improvement program, have someone that is internal to your operation. Don't make it IT. Make it someone that's in operations that knows the machines, and make them and have them drive it and work with the provider. Select the right resources, manufacturing engineering or maintenance or operational people. Get a lot of people that are not just data people on the team, so that everyone understands what's going on. Define any kind of limitations or constraints, such as budget or security or any IT related restraints that might be there. And then you're down to which assets do you want to monitor? Which are the critical assets that you really need to get the information from? And then finally, select a manufacturing IT solutions provider, such as the Freedom Team, to help you implement the solution. Okay, so what are the components to the smart manufacturing data collection side? So for our solution is that we bring the full suite. Okay, so we bring the connectivity piece, we bring the data standardization and cleansing piece, and then we bring the application that we call Freedom. We bring that to the table as well. All right, so for us is that we will take each one of these machines that you see with a yellow dot, and we'll say, what kind of machine is it? Is it a machining center? Does it have a fanning control? And what kind? What kind of controller is on it? What kind of machine is it? And then we'll put that into what we call a site survey. And then we take a look at that and we decide how we're going to deploy the connectivity piece. We'll even talk about what kind of data items, and I'll get to that in a few minutes. What is it that we're actually going to collect and we're going to monitor. With what we bring as a solution is that we have an interface for every machine out there like I mentioned earlier, any machine on the planet. So if you have a modern machine, is at 80% of the time, this is a software-only interface. So we'll take the interface and put it directly on the machine control itself. It'll run directly in the background on a FANUC or a Siemens or a Mazak or a Kuma controls. You know, it just sits there quietly, and it takes the data from the control and sends it out in a standardized way to the Freedom cloud. And we can deploy our software both in the cloud. We can also provide it behind your firewall. So whichever choice that works for the company is how we'll deploy it. It's real time. So anything that you look at in the Freedom is virtually within seconds of what is actually happening on the machine. You have user configurable dashboards. So instead of looking at canned reports, you can actually make your own look and feel into to what you want to display, like say on an Andon board. Multi-user, multi-tenant. All right, so that means is that you could put it in a location in a data center behind a firewall, but you could then section it off to where it could monitor multiple plants within the same organization, and you could keep that data separate, from plant to plant. It's very flexible, so you can configure it for the downtime categories, downtime reasons. You can do all of that very flexible in the way you set it up. It's multi-user. All right, so you can have as many users as you want. It's also web-based, so you access the software through any standard browser. So Chrome, Internet Explorer, and so on. We also have the ability to integrate with other platforms. So we've integrated with different types of ERP systems, and probably one of the better ones or better use cases is to integrate with CMMS platforms. And we've done some work with Mr. LaChance is sitting here in the audience, with Dude Solutions, So I think it's a natural fit when we integrate it with, other line of business systems. What are the adapters, all right? What actually goes on the machine? Software is most of the time. And so just a small list of some of the controllers that we can integrate with, and installs in minutes. It's about a 10-minute install, and then we're up and running. But for those other ones, all right, so those legacy machines, is that oftentimes that is a hardware appliance, all right? And so we can actually find an appliance, and they might have a stack light or something like that, and you can actually wire right into the light itself. At least we understand when it's running and when it's not running, and so on. Use cases and data items is that we start off with really three kind of categories. There's basic use cases, standard use cases, and sensors. So for the basic, which is really the hardware appliances, is there things that we can monitor, like whether the power's on, whether it's in cycle or out of cycle, whether it's in a fault condition or not. Probably right there in the middle is the more typical one. So the use cases are typically, we're looking for OEE, availability, utilization, some performance or efficiency type requirements, machine health and process health. And there's a long list of items that we collect, that we can, we collect those items, and then we can turn that into actionable information. And that's really the sweet spots right there in the middle. Now with all of IIoT coming online is that there's more and more data that's available. So we can get more information out of the industrial controls, and that can be more sensor related data. So there is that we're getting much higher frequency data, which is axis positions, motor speeds and feeds. We've even done some work with fluid chemistry, like understanding, the coolant concentration and pH, within a coolant system. So there is that oftentimes is that either the data is available already in the control, or we can provide the sensors and put them out and actually supplement the data that we're already getting, from the control itself. So why us? All right, so why work with 5ME? Why work with the Freedom team? And I think that there's really three things. Is that it's a pretty rapid, low-cost deployment, because most of the time we're bringing a software interface for all the machines. We're also deploying, a web-based type of solution. Is that we get in and we get out. I mean, so it's pretty easy for us to do, say, 100 machines in about 4 weeks. All right, and there's no really special engineering. We're not coming in and changing NC programs or PLCs. Like I said, most of the time we're trying to do a software install. The second thing is that it's 24/7 actionable information. It's pretty simple software. Be happy to demonstrate it for you, but it's a point and click, and you can usually drive into and find something that's very meaningful to you. It's been designed by guys that have had to use it themselves, in their own production environments. Third, and maybe the most important thing, is the value, is that it's a very light architecture IT footprint. We're not bringing a lot of computer components to the table. There's no third-party type of licensing or fees back to people like Microsoft or Oracle or anything like that. There is an annual maintenance fee with us, so that keeps you to the latest version of the software. You get support, and for us is that in almost every case is that if you can raise your efficiency 3%, then you'll pay for this software in about 6 months. Almost in every case that we've ever run into. The value prop for us is that it's really that third one, is that we've seen as high as 50% documented productivity improvements. I'd say on average, it's probably closer to 20%. So we install the software, we make it really visual out on the shop floor with Andon boards, and involve everybody. Minimum 10, most of the time 20. I have seen it as high as 50% productivity improvements, just by monitoring, making it visible, and involving everybody. A lot of other things come along for the ride when you do that. All right, so you have, of course, increased production output. Is that you do more with the existing capacity, that you have. One of the bigger items is that we've had several facilities within Caterpillar to where they've taken days of WIP and days of finished goods off the shelf because they're turning the product a heck of a lot faster, right? And that ends up being millions of dollars that you don't have sitting around or sitting in between, operations. Okay, so I'm going to show you just a few screenshots, from our software. So just to give you an idea of what it looks like. And then, again, please visit us in the MAG or the Sagino booths in the South Hall, and we can show it to you live as well. Okay, so just to acclimate you here is that this is a browser. This is actually done in Chrome. Is that there's a couple of things there at the top. You see it says 5ME MU8000 cryogenic. So that's a drop-down list. So you'll have a list of all your machines that you're going to monitor with it, within your facility that you've connected. So you can choose one of those machines. You could choose a list of machines. Could be that you have a value stream, and you could put several machines into a list. You can choose a report down the left-hand side. In this case, we're looking at a stack bar, and then you can choose a time frame. We're looking at 1 week from the 19th of August to the 26th of August. The colors mean something. They align to an AMT document that came out about 15 years ago. All right, and so it is in categories of operations. So the green is always in cycle. We're running, adding value. All right. The blue is a category that says that we're in a process. We're adding value. Machine's not running. So that could be things like setup, plan gauging, tool changing, things that are inherent to the process, but it's not while the machine is running. The yellow and the red are places that you really want to attack. All right. So that's where the yellow is that we're in a delay, waiting for something, or going to meetings or other types of things. And the red is repair. All right. So the machine is not running because it's in a repair state. And the rest of that is we're not scheduled to run. So the software supports any kind of schedule, whether it's 4/10s, 5/8s. You could do a rotating bi-weekly type of schedule, so each machine can have its own unique work schedule. So we do all of that automatically. So we know exactly when the machine is running, we know exactly when the machine is not running, and we drive all these metrics automatically. When the machine's not running, we create downtime events. Those downtime events can also be edited by anybody that has user access, and they can change those events to more meaningful things. So a little more detail about why we're not running, But for most of all this is that it's fully automatic. This is a little more detailed view. So this is chronologically from midnight to midnight for 1 day on a Sagino Xeon machine. So here you can actually drill into, and you can figure out how many alarms on the top line have occurred on the machine, each hour. The second lines are where the feed rate and spindle speed overrides have been in the course of that hour. So those are usually dials that an operator can turn up or down and impact the speed and the feed of that particular machine. You also can get part durations. You can look at, in that gray bar, what programs are active on the machine. The green is how often they run. And then those other multicolor down below, those are all the downtime events. So those are all the downtime situations that we have recorded when the machine has not been running. So what I showed you before is sort of the standard screens or the standard reports that are part of the software. I'm going to switch gears a little bit here, and this is our smartboard dashboarding type product. And here, this is a little more visual, a little more graphical. And what this is that you can create as a user any view into the data. And so this provides an editor. Everything that you see in a window in here is actually a dashlet or a widget. And you drag and drop in size and place those actually out on a canvas of your own creation. And it's very simple to do, and you can create the view that's important to you. And we found this to be really impactful to put it out on Andon boards and put them as part of a slideshow within our software so that we can make it really visual. And you can make them as simple or as complex as you want. This case here is this is a very simple case to where this operation was a stamping operation. So it's pneumatic stamping. These are very old machines, probably 30, 40 years old machines, purely pneumatic. All they have is a flywheel, and so there's no electrical data that we could get off of it. What we did is we just put a pressure switch so we know when the buttons are pressed, and so we're collecting one piece of data off of each one of these presses. But look at what all we can do with it. So these things are live, and we're getting real-time part counts. Every time the press cycles, we get an Andon light that says it's running. We're counting parts. We can tell the software how often, based on their routings, how often that press should cycle. So we can give you a part variance, hour to hour. And that's from one piece of data that we integrated right off the floor, And it didn't even have anything that we could connect to start off with. So like I said, it's that the use cases are there, and you don't have to have brand new machines, is the point. This is now maybe a little bit more on the other end of the spectrum. So this is this is in an automotive type of application to where you have sequential type processing from Op10 to 60, automatically fed by an overhead gantry. You'll see this at the MAG booth. So here is that we're looking at how many parts are produced. You can see that in the round circles. The inner circle represents whether the machine is running or not for that right now. The outer circle would represent how much it's run during the shift. So it's just a visual, it looks like about 50%, for Op10. You can understand exactly how long it's been active, what the mean cycle time has been. A good example here is that the takt time of this line is a minute per machine. The one in Op40 is running a minute 15, and you can see that it's red, for the average cycle time is out of bounds, right? So it's pretty easy then for you to come in and identify where some of the bottlenecks are, and you can make and this is a dashboard, that we put together. We're not writing code here. We're just dragging widgets out there, and it's just based on whatever creativity that your team has, to put them together. A little bit different application is that this is more IIoT related, but this is on an autoclave for aerospace industry, to where we're looking at more sensor data here. So in this case is that we're monitoring in this autoclave when it's in cycle, not only the temperature but the pressure, but we're also looking at some of the average fan vibrations within the autoclave, and we put some bands on it. And you can see here, we can see when it's red or green, and the software will support once we hit some of these thresholds. We can send text messages or email reports when you're at some of these, these thresholds. And we're also just throwing a lot of other data that you could look at in a dashboard. This was one that we're a partner in Think with Akuma, and so we participated in a winter showcase last year. And so here is that we had a part, we were part of a team, we were making this valve body. And so as part of this team is that we had to actually inspect the part on the machine using the machine probe. And so we're pulling the data off of the probe as part of the machine, and we're checking to see whether these features are good. So we had a half a dozen features, and we were pulling, nominal data, deviation from nominal. I don't know if I have the chart in this stack, but you could actually, we were showing some X bar and R type charts, based off the data from these features. And we were doing this all in real time, just integrated right with the machine itself. This is an example of some things that you'll see at a Sagina booth. This is also very popular. If you can imagine, like in practice with a, in a plant, if you had like a CAD drawing of your facility with all your machines, you can actually put these little icons that can update in real time, so you get a bird's eye view of what's going on right now. Just look up, glance at it, and you can see, how many machines are actually running and how many machines are not. You can get some other metrics like availability, performance, and all your OEE metrics. All of that's real time and live. And I think this is one of the last ones. Is a lot of time what we've been talking about so far has been OEE and percentages and time and downtime and all that. So this is kind of a different twist, all right? So this is more financial related. So what's capable in our software is to put an overhead rate for each one of the assets. So that here is that you can actually look in dollars and cents on whether the asset's making money or not at any given moment. Which is also a bit impactful, is that when people can see that in money terms versus just time, then that sometimes has a different impact, right? So we can tell, like, here is that this asset is making, the line would say is that this asset is actually making money, today. So just another one of the standard reports that comes with the Freedom platform. Okay, so what I'll leave you with is that I've shown you a lot of examples. We bring the whole suite from the connectivity piece all the way up to the monitoring piece. We can share data with other platforms. So I'll leave you as that, when it comes to data monitoring, no matter what you have on the floor, you can connect to it. All right, so get started. Begin with the end in mind, but begin. Start at the edge. And what I mean by starting at the edge is work it from the ground up. So in other words, talk about what the use cases are, what kind of data you're going to require. Do that at the edge. Edge means closer to the machine itself. Then you work your way as part of the monitoring program. When you actually choose a solution, hopefully a Freedom solution, is that when you have adapters, make sure they conform to a standard of some sort, like MT Connect, because that gives you some open options. Get some quick wins, that align to your pain points. Choose machines that are critical. Choose things that are causing you problems right now. Keep it really simple when you start off. Even if we'd love to take a 100 machine order, but a lot of people might start with 10, and try to gain some momentum and get some wins. And then use a manufacturing IT solution provider such as Freedom at 5ME. Thank you very much. I can take some questions. No questions? Okay, if you have some, we'll be over at the booth the rest of the day. Thank you very much.